Okay guys, here we go. Is 3 to the power n bigger than n squared for all n greater than equal to 2? We're going to do this one again, alright? So step 1 is test the lowest value in your range. What's the lowest value in our range? 2. So test n equals 2. And for 5 marks, here's what we do. 3 squared is bigger than 2 squared. 9 is bigger than 4. True for n equals 2. We're all good, are we? Hooray, alright? Next thing, assume true for n equals k. Wait. So assume true for n equals k. So here's what we're going to do. 2. Assume true for n equals k, and we'll just do this such that 3 to the power k is greater than k squared for k greater or equal to 2 k elements n. Now we finally get on to the only bit that's difficult, is part 3. Alright, so what do we want to do now? Prove for okay, so you're like n equals k plus 1, no bother, and what we're thinking here is 3 by k plus 1, okay, greater than 3 times 3k1 is greater than k plus 1 squared. Would you agree with that? Now, the problem here is they're speaking two completely different languages to each other. Okay? So it's 3 times, everybody agree it's 3 times 3 to the power k? And that's greater than square that out. And that doesn't help matters at all. But here's what I'm saying from earlier. 3 times a big number, and here's the red one's the big number, the blue one's the small number, and if I replace that with 3 times what's a k squared, and if I prove that 3k squared is bigger than that, that must mean, and you can also go over here as well, you can sort of do it like this: 3 to the power 3k. You can do a triple. If you don't like the presentation, I'd recommend doing a triple one. And what I mean by a triple one is like this: 3 to the power 3k is bigger than what? 3 times k squared, yeah? And we in turn want to prove that that's bigger than k squared plus 2k plus 1. Now you might want to explain what you did. What do we say there? Assume true by? And we might just spell it out a bit more, that 3 to the power k is greater than k squared. Is that okay? Now we're focusing on what's in the box. Everybody ever see the movie 7? What's in the box? Alright, so guys, we're going to try and do this now, alright? So here's my plan. I'm going to move everything to the left, and I'm going to try and make some type of perfect square out of it. That will help matters, okay? So what I'm going to say is k squared cancels with that turns into 2k squared. You happy with that? Move over to the left, so we're going to get k squared minus 2k. Oh, and I broke up the 2k squared into k squared plus k squared. Is that okay? You'll see why I did that in a second. Now bring over the minus 1. And I'm still going. Alright? Now because I've done many of these, a couple of books worth at this point in time, I know the tricks. Alright? And here's the trick. Wasn't even in the solutions of the text and text, right? So what we have is this. I'm thinking perfect square. And anytime I get these type of quadratics, I'm always thinking perfect square if I'm stuck. So here's what I'm going to do. I'm going to change that into... Am I allowed to do that, or do I have to put in a balance? To what? Exactly. Alright? And now I'm going to rearrange it. I'm going to put the k squared minus 2 beside each other. Is that okay with you guys? And what am I going to do here? Perfect square that. And why is all that bigger than 0? Greater than 0 because what? K is greater than equal to 2. And greater than 0 because it's a perfect square. So what does that mean overall? Yeah, I'm going to do the whole thing. Can I just call it out at this rate? So n equals k plus 1 is true if n equals k is true. Hence, by the principle of mathematical deduction, I'm just going to copy and paste this and have it ready. Look at question 4 while you're waiting. Hence, what? Yeah, I'm just still typing, but yep. Right. Hence, by the principle of mathematical deduction, it's true for all n. I'll just write the rest of that down. N greater than equal to 2 n elements n. Is that alright with you guys? Alright, have a look at question 4. Anybody out today? Alright. So lads, something very important that we want to show you here, okay? Ready? Ready for this? 5 factorial means, you should already know this, but we don't use should anymore. Let's just assume you don't know it, right? And everybody happy that 4 factorial is 4 by 3 by 2 by 1. Everybody cool with that? Would everybody agree that 5 factorial could be written as 5 times what? Exactly. 5 times 4 factorial. Right? That's the key bit of understanding you need to do these questions, right? Now, an example. If I had n plus 2 factorial, what could I write that as?
N plus 2 by n plus 1 factorial.
I could write it as that. That's perfect. What else could I write it as? I could write it as n plus 2 multiplied by n plus 1 multiplied by what? Does anybody have any questions about this part here? Alright, if you aren't sure, see 5 factorial. Ever see 5 factorial? I could write 5 factorial as 5 multiplied by 4 multiplied by 3 factorial. See the way I can just keep shifting it downwards as I want? I can go as low as I want really until I get to 1 factorial, I suppose. You're familiar with that? Okay, here's hoping. Now, we're going to do the usual. Prove for n equals, prove for, what is it? Prove for n equals 1. Alright, this should be easy. 1 plus 1 factorial greater than, oh sorry, I'm wrong. I was just looking at that going, that doesn't work. So n equals 2, right? So 2 plus 1 factorial greater than 2 to the power 2. 3 factorial is 6. 6 greater than 4. True for n equals 1. Okay, I'm just going to shrink that. It's taking up too much board for what it is. Yeah, monkey there. Alright, let's go to part 2. Yo. Alright, good man. You should do that after you get your mock results. Okay, guys. Next one. Assume true for n equals k. So k plus 1 factorial greater than 2 to the power k for k greater than equal to 2 k element n. Alright with that? Right. Part 3. Pièce de resistance. Right. Said completely wrong, but anyways. What happens when we replace n with k plus 1? So it's no longer going to be k plus 1. What's it going to be? K plus 2 factorial. Okay? And what's this going to be? 2 to the power of? K plus 1. Alright, have an idea. It was what I showed you earlier. You need to use part 2 to answer part 3. In part 2 we had k plus 1 factorial. So what do you think I'm going to do? What's my move?
K plus 2 bracket k plus 1 factorial.
Excellent. And that's 2 times 2 to the power k, is it? Alright. Now what's my next move now, lads? The triple one, isn't it? So what are we going to prove? K plus 2 by k plus 1 factorial is bigger than what? What can I replace k plus 1 factorial with? not exactly replace it with, but say that it's bigger than k plus 2 times 2 to the k, and I in turn want to prove that that's bigger than 2 times. Oh, this turned out nice and easy now. Alright, you do have to explain what you just did though. Yes?
Why did you put k plus 2 in the middle one? In the red one?
Oh, so if you look at this, I'll highlight this. Very good question. Very good question. See that yellow part there? That's that part specifically. And what I'm saying is a number multiplied by this number. The yellow part is the big number. The blue part is the small number. Everybody agreed yellow bigger than blue? Assume true. So any number times yellow will be bigger than any number times blue. Do you get what I'm saying?
Yeah.
So any number multiplied by yellow will be the same as the same number multiplied by blue. It's bigger than. Alright? So what we're just going to do here is we're just going to explain that assume true by. What is it assume true by? As we'll just spell it out a bit further. K plus 1 factorial is greater than 2 to the power k. Yes?
Where did you get the k plus 2 by 2k from the last one?
Okay, yep, that's what he asked me, but we'll go again. Alright. Are you happy with part 2?
Yeah.
Are you happy that the yellow number is bigger than the blue number?
Yeah.
Alright. And are you happy that this k plus 2 factorial here turns into k plus 2 by k plus 1 factorial? Now k plus 1 factorial is the big number. Alright? The problem is it looks nothing like what you're trying to prove it's bigger than. Okay? So I'm using a substitute. That's where we get the treating from. I'm saying k plus 2 times the yellow number is definitely bigger than k plus 2 times the blue number, because the yellow number is bigger than the blue number, assumed in part 2. Therefore, if I prove that this middle part is bigger than 2 by 2 to the k, it has to mean that this part here is also bigger than it. Okay, that's where it's coming in. That's the logic involved. I'm going to stop and we'll have a discussion here about this. Excellent, it'll be grand. Alright, next thing we're going to do is this. We assume that the yellow number is bigger than the blue number by step 2. Alright? Now the goal is to prove that the middle part is bigger than the right hand part. So let's multiply that out. So what's it going to be? K times what? K times 2 to the power k is greater than what's 2 times 2 to the power k, anybody? Actually, we don't even have to do anything. Look. What happens to the 2 times 2 to the k's? What am I left with? Why is that true? K greater than or equal to 2, and this is a guaranteed, why is it a guaranteed positive number? It'll either be a really small fraction, or it actually can't be a really small fraction, can it? Because it starts off at 2, so the minimum value is 4. Guaranteed positive number. So, are you happy enough with that? So what can I say then? Oh. Hooray! Right, a bit faster. Okie dokie. So, I'll tell you what, lads, we're just going to go straight to step 2 and step 3, okay? Alright, assume true for n equals k. Assume true for n equals k, and what we have is 2 to the power k is greater than 2k plus 1. Now please remember, people at home that never ever look at any of these, that we've skipped part 1 to save time, alright? Now we're going to prove for n equals k plus 1. So we have 2 times k plus 1 greater than, now replace that k with k plus 1. What's that, 2k plus 3, lads? Who got that far? Hooray, everybody, alright? Now, here's what we're going to do. We have to make part 3 look like part 2. So I'm going to modify part 2 here. Is everybody happy with the rule of indices I just used there?
Yeah.
Okay. and I'm going to say that is greater than 2k plus 3 still. Now, what I'm next going to introduce is this yellow number here. That yellow number there is bigger than this blue number here. So, if I introduce an intermediate part where I say 2 times 2 to the k, so the red part, and I say that's greater than 2 still there, but I'm subbing out the 2k for 2k plus 1. Okay? I'm saying that 2 to the power of 2k is assumed bigger than 2 times 2k plus 1. And in turn, if I can prove that 2 times 2k plus 1 is bigger than 2k plus 3, that means that the middle one is bigger than the one on the right, and we've assumed that the one on the left is bigger than the one in the middle. Okay? Therefore, the one on the left is bigger than the one on the right, which is what we wanted to prove in the first place. Will I say that slower? Alright, much slower.
Smaller than 2k plus 3.
Okay, I haven't finished yet.
2 by 2k plus 1.
I haven't finished yet. Okay, shh. Once again, lads, is everybody happy to this part here, the black box? Okay? Now, what I'm basically doing is I'm saying that the yellow part here is the same as the yellow part in part 2. I'm saying that the yellow part is bigger than the blue part. So, 2 times the yellow part is assumed bigger. Oh, sorry, that really messed things up. 2 times the yellow part is assumed bigger than 2 times the blue part. Everybody happy with that? Therefore, if I can prove that 2 times the blue part is bigger than this green part, then that's just as good as proving 2 times the yellow part is bigger than it. Okay? So that's what we're looking to do. So, you would write down a quick thing here saying it's assumed true by n equals k that 2 to the power k is bigger than 2k plus 1. Now, let's concentrate on, you would write that down formally, okay? Now let's multiply this out and we get 4k plus 2 greater than 2k plus 3. And happy days, look at this, 2k is going to be bigger than 1. Why is that true? True as k has to be bigger than or equal to, what's it say to start? 3. And then you just, oh, my spiel is gone, but you write down the principle of mathematical induction answer. Is that right? Alright, for homework tonight, you guys are going to try, what did we do already? We did 1, 2 and 3, didn't we? And we also did 5. So you guys try 4, 6, 7 and 8.